giving me this opportunity to present. So the title says External Corrosion Management Perspective for Structural Integrity. So far, like we have seen, it is more of internal corrosion that has been spoken and managed, but then the crux of it is the external corrosion, the structurals, and the piping or that is also very crucial from asset integrity point of view. So the august graduate, the learned participants here, they know what the corrosion is, and most of the cases, the type of corrosions are being managed, and generally we don't resort on the root cause analysis, and that's the essential key. Actually, we should be knowing the root cause and try to so when it comes to corrosion, the way you can manage or you can control corrosion is of course the design. So having corrosion allowance or corrosion resistant material based on the chemistry or the fluids that are being handled, the temperature, pressure and process conditions. Alter the environment like by addition of corrosion inhibitors or the additives. Alteration of the design like the supports and the stresses should be minimized to avoid different types of corrosion. And since all our assets, the refineries, even the power plants, what we heard in the morning, is more than maybe 50 plus years, 5 decades now. So the last two resorts are very much within our control. That is the protective coating and substance in conjunction with the cathodic protection. And like so far we have done we all know here that for corrosion, when it comes to corrosion, it has been inspected and monitored. And general tendency is to manage by replacing with the same material. So when it comes to management, it is like the top-down approach is very important. And now like we have awareness in the country. So when it comes to corrosion management, we should emphasize on the corrosion control details, like the one I spoke in the earlier slide. And it is more of a long-term thinking, the competency, experience that matters. And proper data informatics has to be there, and that is how it can be controlled or mitigated. So when you look at for our aging assets as such, the residual life assessment, the next speaker will be speaking more on it. So that is more important. So what we are trying to look at is extension of the life, and of course the condition monitoring and the failure analysis. So we have to pay more details to the attention to the details of it. So when it comes to corrosion management, it is more of working procedures and the plans that are in place, but it has to go up. And if you look at this corrosion management triangle, the more corrosion specific elements have to be implemented. That is where the management role comes into picture. And to enable the control measures, it is more important that the organization should have the culture for it. There has to be proper communication and the training and the competency. And more than that, the management support, the management review is also important. So when we speak about the life assessment or life cycle management, we all know here that the corrosion, global economy, the cost of corrosion is around $2.2 trillion every year. This is the data from the World Corrosion Organization. And when you look at the corrosion, the cost of corrosion, it can be saved around 30 to 35% of cost of corrosion can be saved if you control it with the proper corrosion control measures. And one of the damages which are unseen or unknown, like we don't realize, those are damages, external corrosion, that is corrosion under insulation, and it accounts to around 20 to 30% of corrosion. So if you look in this plot, this is very much interpretation of the pie chart from our refinery. If you see here, the corrosion under insulation accounts for almost 35% of the corrosion or deterioration in the material. So before like you have corrosion management in place, it's important to have our asset integrity in place, and the management strategy has to be there. There has to be predictive maintenance, and the asset management planning falls in place thereafter. So just now I just told you about the corrosion under insulation. If you like, sorry, the surfaces are not. Actually, it is not visible by eyes. Right now, when Dr. David from Shell showed that monitoring has been done, it's a visual thing. But then this corrosion is occurring under insulation. So we are not actually seeing what is happening underneath. So here, like consequence is loss of the integrity of the structure. It could be structural member or the process fluid which is there. So there are several reasons why the corrosion insulation has to be there in first place. Rather, insulation has to be there in the place. And then this corrosion is such that it generally occurs with presence of corrosion will occur obviously due to presence of moisture and the cyclic temperature. So when the equipment or the asset, whether it is in shutdown condition or in operating condition or cyclic condition, this corrosion under insulation will happen. So generally the major corrosion control measure for CUI is application of aluminum foil, 63 micron aluminum foil, followed by but the insulation and the jacketing with the vapor barrier coating and all that, and weather shielding will be there. And in the corrosion control measures for CUI are also very well mentioned and specified in NACE SP 0195, which mentions the various coating for corrosion protection at given temperature ranges and all that. So there are guidelines present, and even API RP 583 standard is available, and it is found that most of the corrosion will occur in the range of 50 to 175 degree, and mostly when it is cyclic, it will lead to CUI. So corrosion under insulation, as I explained, it's a hidden enemy, and it's like actually too late when the disasters can happen. And the corrosion can be in form of loss of containment, equipment failure, and to an extent it could be catastrophic that there have been explosions reported. And there is also reports like by MPP saying that approximately 35% of incidences, which also coincidence is not actually incidences, but the corrosion in general around 35% occurs due to corrosion under insulation. Now, why insulation? So when you look at it is mainly from energy conservation point of view. Somewhere even heat conservation is required, or the process control, like we have to maintain temperatures above the dew point. So that is why we have heat process control for that, heat tracing, above which we need to have CUI, corrosion insulation. Then it is also used for cold conservation, condensation control. Sometimes it is also used for attenuation, the acoustic attenuation, and of course last but not least reliability and the safety, because there has to be safe temperature. And as you might maybe all aware that the extent of corrosion under insulation is as high as 20 times more than what natural atmospheric corrosion can occur. And the extent of corrosion can be like 1.5 to 3 mm per annum. This is based on the Bayesian network. If you look at, there are various parameters affecting corrosion under insulation. It depends on the time of wetness, it depends upon the temperature, it depends on the material of the construction. Like it could be general corrosion when it is carbon steel, and it could be pitting or localized stress corrosion cracking in case of stainless steels. So if you look at, as I earlier explained, that corrosion under insulation will occur if the heating and cooling occurs, presence of moisture, and other parameters, like if like most of our refineries are located at the coastal area, so it has ionic species into it. Salts are it is contaminated with that, so it is highly conducting, and that is how like the water will ingress or percolate through the insulator. So it permeates through it and it settles on the metal surface, and at 6 o'clock position where there is contact of water, the corrosion under insulation will occur. So all this combination, like the air, steel, and water, will lead to corrosion under insulation. So based on this, like consequences, we all know it is a direct corrosion loss or indirect in terms of reputation of the company as well, and the production losses also. The manifestation, as you can look, it looks really ugly, but in such a case, I mean, it cannot be even if you look at the fasteners and all that, we cannot even reopen and again fix it back. So the damages are really dreadful, and nothing can be done. So as I told you earlier, there are guidelines available in 0198, and if you look at the temperatures from minus 45 to 250, epoxy or novolac phenolics can be used. but this is the coating over which again insulation has to be there. So we have to again ensure that the coating is intact. There are no holidays or gaps in the coating wherein the water can still percolate behind and lead to CUI. Then for higher temperature, we further go ahead with thermal spray aluminum. Again, it's debatable whether it has to be sealed coating or it can be directly thermal spray aluminum. It's again a sacrificial type of coating, so it will also corrode to some extent. Then for further higher temperatures, there are metal metric polymers available, and there are various producers, manufacturers for this type of coating. Yeah, I'm done. So API 583 again gives the guidelines, and recently in 2021 only it has been revised, and it can involve around 2 to 200 mils of this coating for personal as well as heat conservation, thermal conservation. So when it comes to CUI, this I have already spoken of. So as the transition occurs and with awareness and based on our performance, functionality and the final usability, insulating type of coatings have also come in the market now, and there are various suppliers for this. So based on what is our final requirement, reason for selection of the insulating coating is whether it is fireproofing or thermal. Fireproofing is also one of the aspects wherein we have to look into it, that corrosion doesn't occur for the structures underneath the fire proof coating. Then whether it is for thermal insulation or acoustic, that I already spoke of. So if you look at for hot insulation, mostly for personal protection, we can go ahead with thermal insulating coating. How do we go about selection of the thermal insulating coating? So we have to identify the prone areas, then identify the risk or criticality of the area, then consider safety, of course, and then based on the process and if we want to go with the first, like class 3 hot insulation, metallic guards are the conventional option, but apart from that we can go ahead with the heat insulating coating, which can save almost 90% of the volume, and even the requirement of the space will be less when you apply these coatings. And these coatings are up to it varies, like it can be up to 5 mm thick also, or based on whether it's the process control, then we will have to go with higher thickness of it. So based on this, the thermal insulating coatings are actually very friendly with respect to installation and maintenance, and here we can actually visualize. There we need not go with the brute cutting of the insulation for the inspection. It is repairable, of course, because it's based on polymers, and it has ease of application. So when it comes to inspection, API 510 gives the guidelines where brute forcing is done and it has been inspected. So for the refinery, we generally have identification of this line, then the inspection coating repair is done locally only. So the inspection techniques like radiography or thermography has been done. So I just wanted to pose question to this August gathering, whether anything else can be done in context with India as a country with respect to CUI, because this is not the problem which is experienced by any one of refineries or any other. It's in general for all, be it a power plant or any other asset. So thank you for this, and finally I'd like to say that it's rust that will never sleep. Thank you.
Thank you.